Yeah, okay. We are going to see the some anomalous property is in a different group. Here we are going to start with group 1. In group 1 you have some elements such as lithium, yes, hydrogen. Those elements have special features or anomalous property. Yeah, we are going to see those anomalous property. Yeah, here hydrogen, yes, has a smallest chemical element. Yes, is gas at room temperature. Yes, other are solid. Also is non-metal when react with active metal. Means that when react with inactive metal, yes, hydrogen is metal. Means that have the property to be metal and non-metal when react with active metal. Means that those are some anomalous property for hydrogen. For lithium, we have also has small size. Means that if it has small size, it form complex. Also, has high electronegativity. Yes. Also has lithium has a high pricing power. Means that form covalent character. Yeah, means that those are the anomalous property of lithium. Have small size, high electronegativity, and high pricing power. This is not for barium, not for barium. Yeah, those are anomalous property of hydrogen and lithium. Lithium also has some anomalous property the same to group 2. We are going to see. In group 2 we have barium. Barium has special features such as barium has a small size, means that it form complex. Also has high electronegativity, high pricing power, means that it form covalent character. Also form complex, means that this is a complex. When it is amphoteric, it is amphoteric. When you react with oxide of barium, when you react with base to form a complex. Also, barium is soluble in non-polar, but other are soluble in polar solvents. Means that barium is soluble in non-polar, but for other group, they may remain is polar in solvent. Also, form amphoteric. Those are the reaction. Yes, those are the reaction. Yes, reaction. Yes, for amphoteric. These are the here the acid react with this amphoteric of barium. It acts as base. Here it acts as acid because it reacts with base. Those are the complex. Yes, also form dimer. Means that dimer, like this, like aluminium. Those are anomalous property of barium in a group 2. We are going to see other anomalous property in a group 3. We have a boron, we have aluminium, we have 2. Boron has those special features or anomalous property. It's a small size, it means that form complex. Yes, also boron is non-metal, other is metal, has a lower density, has a high melting point, and it has a high electronegativity. Yes, also has a higher charge over ratio. Those are anomalous property of boron. Also aluminium has also anomalous property. Means that aluminium is a metal with low density. Yes, has a high melting point and electronegativity. Yes, also aluminium has that properties shine Shine means that when when the light pass on the aluminum, they have shining property. Malleable means that can be hammered into a sheet. Also has this property of ductile, means that can be drawn into a wire. Also have that property of amphoteric oxide. This oxide of aluminum as amphoteric means that amphoteric is oxide that react with acid and act as base. It act as base and acid. Here it act as base because it react with this acid. Here it act as acid because it react with base. Those are the product. Yes, these are the complex. I'm going to see in a group 14. Yes, we have. Before we are going to see in the group, the friend group, we are going to see some uses of aluminium. Aluminium are used in making aircraft or airplane due to or small boat. You see small boat or aircraft such as airplanes due to lighter and lower density. Also in packaging food. We are using in packaging food due to it resists on corrosion. Also here we are using in cooking utensil, home tools. Yes, due to good conductor of heat and electricity. Also it used in firefighter due to reflecting radiant heat. Those are some uses of aluminium in our daily life. Here, let us continue the group, the friend group. Group 14, we have this carbon. Also carbon has we have many elements, but here we are going to deal with carbon. Carbon has two special features. Yes, you see two special features. Yes, ability to form catenation and the ability to form multiple bond. What is catenation? Catenation is the ability of carbon to form a long chain of carbon only. Example, ethane. Here we have those chain is composed with carbon and carbon. Here we have also ability to form multiple bond. We have two features, 1 and 2. These form multiple bond. You see single, double, and yes, also double. Those are the features of carbon. Also in nature, carbon is found as pure, like diamond, gravity. Diamond is bad conductor due to no free electron, means that all electrons are closely packed together, whereas gravity is a non-metal. Yes, no, is a non-metal. This is a non-metal, but conduct electricity due to free electron. We are continuing in a group also 14. Some other key point you have to know: stability of oxidation state of +2 and +4 in this group. Means that downy group oxidation state of +2 increase, whereas oxidation state of +4 decrease. Means that downy group oxidation state of +2 increase, whereas +4 decrease. Example, here we have except before I went to see, let us see those examples. Here there is a stable and an unstable compound. Yes, +4 yes is a stable. +4 is a stable. Yes, is a stable. +4 is a stable in this. Here we have +4. Yes, we have +4 is a stable in this compound, but except here, yes, we have lead is only +2. Means that lead is stable only +2, but in +4 is not stable. Why? Due to inert pair effect. This inert pair effect cause lead plus 2 to be stable rather than plus 4. Means that here in a stable you have this one in plus 2, oxidation state of plus 2, except this lead. Lead is on plus, here it is in plus 4. Why? Due to inert pair effect. Cause lead is on oxidation state of plus 2, it is stable. Here it is unstable. Generally, plus 4 is stable, but plus 2 is unstable. Except on lead. Yes, lead is stable on plus 2 due to inert pair effect. Inert pair effect, by definition, is inability of 2 s electron to participate in chemical bonding. Only 2 p electron involved in chemical bonding. This inert pair effect occur in this element. Also, we have the oxidation of plus 4 form covalent character. Oxidation of plus 2 form ionic equation. Those are the equation. Question. Explain why this lead tetraiodine and lead tetrabromine don't exist, whereas lead tetrachloride exists. Why? Because bromine and iodine are not stronger oxidizing agent to convert lead from lead to lead plus 4. Means that chlorine is a stronger oxidizing agent than bromine and iodine. Let us continue with the following group 15. Also, before we continue, here we have some other key points you have to know. Inert pair you have seen, but we are going to see diagonal relationship. What is it? It is a similarity between pair of elements in the different group which are adjacent to another. Those period are period 2 and period 4 on the periodic table. Means that diagonal relationship is a similarity. These elements that I found in different group but have the same similarities or properties. Here we have a pair. We have 3. Lithium and magnesium have a similarity. And the boron and silicon have the similarity. Also, barium and aluminum have the similarity. Here we are going to see those similarities. Similarity between lithium and magnesium. Here we have this form normal oxide when react with air. The composition of nitrate when lithium, example lithium nitrate or magnesium nitrate, it forms those gives nitrogen dioxide and oxygen. The composition of means that you form lithium oxide plus nitrogen dioxide plus oxygen. Also, the composition of bicarbonate don't exist. Means that bicarbonate of lithium and magnesium don't exist in a solid state, but they exist in a solution. Means that bicarbonate of lithium and magnesium exist in a solution. Those are the similarity between lithium and magnesium. Here we have a similarity between boron and aluminum. All form amphoteric. We have seen other form basic. Failure resistance and less amalgamated means that failure to react with acid. Here we have seen is a passive in acid due to oxide filling on surface of metal. Means that when it is not reactive with acid due to this filling that prevent those reaction of acid. Also form a covalent compound. So let us continue. Also, we are going to see similarity between boron and silicon. Silicon have the similarity. Those are the similarity. All are non-metal that exists in 3 lattice means that metallic giant covert means that it has due to those three lattice means that it has higher melting point. Also it is a semiconductor or a semiconductor form weak acid like this and this. Also form covert compound and they are almost the same density, means that they have the same density. Here oxide are soluble in alkalis, means that those oxide of boron and silicon are soluble in alkalis. Alkalis is a base. Here this is a base. Those are the alkalis. Means that those are the product of this reacted. Here also form numerous volatile hydrate, which means that it is a volatile means that volatile hydrate means that it catch when the fire is nearby. Those volatile means that can be catched, means that when exposed on air also readily hydrolyze it. It readily hydrolyze it. Also can catch fire when exposed on air due to volatile. Those are some similarity between boron and silicon. Let us continue with the friend group. We have this group 15. We have nitrogen, which are diatomic in nature, and other are polyatomic. Example for this phosphorus in nature are polyatomic. We have this like this plus 4. Whereas sulfur in nature, it is like this, have a zigzag arrangement in nature, but nitrogen it is diatomic. It is diatomic with this percentage. Other special features of nitrogen have a nova cat orbital, but other has diva cat orbital with this. Also at moderate temperature, at lower temperature, nitrogen acts as inert, means that due to triple bond. Carbon has a triple bond. Means that at low temperature it acts as inert, not react in easy way. Also is reactive due to inertness at moderate temperature. I think that they are the same to this paragraph. Also phosphorus in nature is polyatomic, means that polyatomic in nature, but other is diatomic. Those are the allotrope of phosphor, and is the white and the red and white phosphor. Those are allotrope. Also allotrope of sulfur, we have the rhombic and the monoclinic. Those are some people to have to know in this group. Let us continue. We are going to see the group 16. We call it chalcogen, whereas group 17 is called halogens. Here we have, in this group we have this element. Here we are going to see oxygen. Here oxygen is a non-metal with colorless, odorless. Also has the allotropes of oxygen. We have ozone. This is ozone. Those are the property of ozone. Ozone is a strong odor, poisonous gas with pale blue and strong oxidizing agent than oxygen. Means that ozone, it is when the ozone are destroyed, we meet with some challenge called global warming due to the excess of carbon dioxide in the atmosphere. Means that also oxygen is stable on this isotope. You have this 16, 17, 18. Those are the isotopes. Means that those are allotropes of ozone. Sulfur also has white and wax non-metal solid. Also sulfur occur in native and found as a free element underground. Also, this selenium is acidic oxide only meteorite. Those are about some key points you have to know in this group. Let us continue. Also, group 16, we continue. Those selenium have to form oxide, acidic oxide only meteorite is a meteorite that form oxide. Here this form amphoteric. Here this also is silvery metallic solid. Also oxygen is a diatomic, other polyatomic, like this sulfur is a zigzag arrangement, means that it has complicated arrangement. To break down those arrangements, it requires high energy. Also we have this some other point you have to know. Anisotropy process means that it is when the rhombic change into monoclinic, or when monoclinic change to rhombic. Those processes are anisotropic. Is when allotrope change from one form to another depending on the temperature. Yes, when you increase temperature, there's a change into monoclinic. When you increase temperature, you decrease temperature from monoclinic to change into rhombic. Yes, we have seen a lot of sulfur, rhombic, and the monoclinic. Those are some property of rhombic and the monoclinic. Here it is alpha, other is a beta. Yes, here is alpha, other is a beta. Monoclinic is a stable below this temperature. Yes, is a stable above this temperature. Is a yellow transparent octahedral crystals and slightly soluble in alcohol and ether, and below this means that those are the some properties or features of the rhombic. Also, let us continue with another group if possible. We have a group 17 called halogens. In halogen, you have fluorine, you have chlorine, you have bromine, you have iodine. Those are some key points you have to know in this group. You have volatile. Volatility is volatility means that you have to put volatility. Yes, volatility is how easy evaporating in boiling point. It means that it is when those higher have the lower boiling point. Example here, fluorine, hydrogen fluorine has this boiling point. Also fluorine has this boiling point. This hydrogen bromine has this boiling point, and this has bring this point. Why this fluorine is a positive? It is due to hydrogen bond and small size with high electronegativity, and also it is liquid at room temperature, but other those are gas. Yes, at room temperature. Those are the reason why it is negative. It is a gas at room temperature. Also has we are going to see halogen bonded dissociation. Fluorine has lower bonded energy due to repulsion between lone pairs. This repulsion causes fluorine bonded dissociation is low. Also bonds, we are going to see reducing power and oxidizing power. Oxidizing power, yes, reducing power is how the anion dissolve in water to release ions. Means that down group reducing power increase, whereas oxidizing power increase. Yes, acidic stress is a dissociation of anions. It is anion, not ion in water. Yes, means that down group increase due to weak nuclear charge attraction. Let us continue. Also, there's the order of halogen bond dissociation. Yes, look at very clearly here. Fluorine has a lower bond in this bond dissociation due to repulsion between lone pair and with small size. Yes, reduced power. How anion liberates ion in water reducing oxidation power and how calcification gain. Yes, ions. Yeah, down group melting point increase due to atomic mass increase with increasing in strength of van der forces, means that melting point increase as atomic mass increase, means that down group atomic mass increase, and also there is an increase of van der forces. Those are some key points, but it is not enough. We have to search in our book for more information. Let us continue with the last group. We have the last group called noble gases. Yes, why is noble gases not not involving reaction due to stable, means that it has 8 electron atoms shell. Also has high ionization energy due to stable. Yes, those are some key points you have to learn in our group. Those are some anomalous properties. For more information, go in the book and read. Thank you for your kind attention. Thank you.